Alright people, let's have a look at this. Okay, we're going to do BC in terms of theta. Okay, BC in terms of theta. Well, what do we know? Okay, this is pretty cool. That's 90 degrees. We could say, well, BC, if you think of number A here, if we use the sine rule, we've got two angles here and a side. We could use the sine rule quite easily. So we could say the length of BC over the sine of the opposite angle is equal to 2 over sine 90. Okay, look at that again. BC over if you take BC over sine theta is 2 over sine 90. Okay, great. And then we can say BC is equal to 2 sine theta. There we go, bring it up there. Divided by sine 90 is 1. So then BC is equal to 2 sine theta. Okay, great. Let's write that in on the diagram there. So this is going to be 2 sine theta for BC. Okay, great. The next question, let's see what it says. It says, show that the length of BD is equal to 1. Show that the length of BD is equal to 1. Okay, well, we've got a whole lot of angles there. We've got the side BC. So once again, we could use the sine rule to do that. So let's go for it. What do we know? Okay, now we're at the bottom triangle, so I'm just going to draw it again quickly, the bottom one. Okay, let's just redraw it so we can see exactly what's going on. That's angle C, B, and D. This angle here was 90 minus theta. We've worked that out as 2 sine theta already for BC, and that's 2 theta there. Okay. So what do we know? We know that if we want the length of BD, we can say BD all over the sine of 90 minus, look at that, BD over sine of 90 minus theta, that angle there, is equal to, let's use that side there, to the BC, which we already know is 2 sine theta, divided by the sine of the opposite angle there, sine of the opposite angle there. Great, and again, remember from grade 11 days, the sine of 90 minus theta is cos theta. This one is going to be 2 sine theta. And then sine 2 theta, if you remember, is 2 sine theta cos theta. Okay, now if we multiply both sides by the cos, we get BD is equal to, look at this, 2 sine theta, bring up the cos, that goes to here, cos theta, all over the exact same thing at the bottom. And guess what? It cancels, and therefore BD is equal to 1 unit as we want. Okay, awesome. Okay, then the C part of the question would be, if AD is root 3, determine the size of angle ABD. Now remember, you've already worked this out as 1. Okay, so you've already got that as 1 unit. So we've got 3 sides, and we want to find the angle. So that's the cos rule. But this is an inclined triangle, as you can see there. So what are we going to do? We're going to go here and we're going to say, okay, let's redraw that triangle quickly. Okay, I'm going to draw it here. This is triangle ABD. That's that slanted inclined triangle. This one doing that. Okay. And what do we know? Well, we've got this is 2. This is the square root of 3, and we've worked that out as 1. And I'm going to call this, let's call this beta there. We want that angle, this angle there. Okay. The inclined angle. Okay. All right. How do we do it? Well, it's 3 sides, so we can use the cos rule. So we can say, well, what's opposite? It's root 3. So we can say the square root of 3 all squared, okay, is equal to 2 squared plus the 1 squared minus 2 times 1, the cos of angle beta. That's the cos rule with the 3 sides. This gives you 3 is equal to 4 plus 1. This mess gives you 5 here. Okay, subtract 4 cos beta. Okay, bring this across, this piece to this side. 4 cos beta is 5 minus 3. So 4 cos beta is 2. Cos beta is 2 over 4. Good. Which of course is a half. And then if you go shift cos that, beta will come to 60 degrees there. In other words, that slanted angle there in here is 60 degrees. Okay, that's slanted one. Okay, guys, I hope you enjoyed that lesson on 3-dimensional trigonometry. Stay with us. We'll be back for more maths on Cell School.